Hi, everybody. So I will be talking today about machine learning in finance. I am Muna Khayyat. I have been working for a few years in Morgan Stanley, and I have been working on a machine learning team. We do specifically machine learning for operations. However, Morgan Stanley has a lot of machine learning systems in different departments, and we have a lot of machine learning in trading, in financial crime technologies, and others. And our team is specified in operations. And today I'm going to talk about machine learning in finance in general. Machine learning is the science of using statistics to create models, and we all know this. And these models will learn from history, and the idea about it that we want to predict something, we don't know it, and usually it's using historical data, but sometimes, and many applications can be without using or without supervised learning, but data is the most important thing in machine learning. In financial institute, there are some difficulties or some things that is not really easy to apply it or work with it. One thing I would like to mention that only 30% of machine learning systems in financial institutes have been going to production. And this means a lot because when we have 70% are just research, it doesn't go to production. And if it didn't go to production for financial institute, it's a cost. And usually this institute, we have this system because we want to take advantage from this system, and it will return money back to us. So first thing that make finance machine learning not easy in financial systems. First of all, research and development is expensive. It's not always applicable to real life applications, and the mentality of the scientists who work in education is completely different than what does the bank needs. In addition to that, the users don't trust machine learning. They want reliability. They want a system that doesn't fail later. So it's hard to trust. And that's why also in banks, we have a lot of regulations on machine learning. So the system, even if it is ready, it's working, it's predicting, it has to go through a long process of auditing to make sure that it won't fail in production. There is no money risk and no reputation risk with this system. So the trust is very important to have this system going to production and working on these machine learning systems. And finally, and this is really important, a lot of people are interested in machine learning. A lot of people attend online courses, learn about it, but the need is really for people who are really data scientists, who have the degree, who has experience on this, and know the whole process, the whole system, because you have to understand everything, not just how to run these tools. And we have a lot of these tools, which makes also machine learning and this affects the trust. When you know that you can run any machine learning algorithm with the data you have, and it will predict. But there are some practices that we have to follow and some rules that we have to follow. If we didn't follow these rules, the prediction won't work in production. Systems will fail in production, and this affects the reputation of machine learning and will affect the trust of machine learning. Many systems we have worked on, it has been worked on before, but didn't work because the data massaging or the data science didn't happen in the proper way. So this is very important, the right people. And we don't have a lot of real data scientists, machine learning engineers, and machine learning specialists. Those people are really needed, and it's not easy to have these people. So these are the challenges that make machine learning not really always easy uh, to be applied or to be productionized in banks. And the benefits and why banks really need machine learning. Machine learning really causes reduction in headcounts, and it reduces cost. And the headcounts usually, and the most important thing, that machine learning replaces most of the time tedious work, which people don't like to work it and to do it. And instead of doing this thing, like looking at, for example, a transaction or screening this transaction, it's really boring, it's very tedious and very critical. And people prefer to do something more interesting in the bank rather than doing these things. So these are some of the reasons that makes the bank really need it, but also there are things on the other side, it makes it hard to have these systems in all banks. Here I am listing some of the applications that we have them in the banks, and they use machine learning. We have a lot of predictive analysis applications in applications which can predict market, and also it can do the financial monitoring. As I have mentioned, you can have the screening process instead of having someone doing it. You can replace this by a machine learning system. And usually machine learning, if it is implemented properly, it does better than human, because also we have human error, and this is always there. And one of the things we have noticed working on machine learning, that the training data many times is polluted because of the human error. So it's there, these systems can do better. So that's one of the things. So we do a lot of financial monitoring. We use predictive analysis, also anomaly detection. It's for high frequency trading. You really need to detect anomalies. For any fraud or in financial crime technologies, they really need to find any anomaly, even in settlement. They need to know, is there any problem with this? And anomaly, it's anomaly when it doesn't settle. It's not the frequent thing. So anomaly detection, fraud detection also, because of security, it's needed. And one of the most common things, and it's applied, it has lower risk, the chat bots, which you just have a question, you can have questions and answers. So these are other things that can be applied in banks. One of the many most interesting applications that we work on it a lot, especially in operation technology, is the document processing and entity extraction. You know, there are a lot of documents that come into the bank, and these documents, people have to read the whole document, process it to extract entities. And most of these documents are semi-structured or completely non-structured. But for example, audit confirms, the audit come, and you have to extract some entity, some informations like the auditor name and the company name and many other information. So these information should be extracted from these documents. And we have built a lot of machine learning systems that do this and automate this process. There is a very good question: what is the relation between high frequency trading and anomaly detection? Because in a high, if any problem happened in the trade, you need to apply anomaly. We have it. We apply anomaly detection. Any problem happen, we need to detect these anomalies in these trades that happen so often and so quickly. So it's just detecting any problems and real problems in the trade. It's real time. And this is one of the interesting things, because they reuse historical document, and this is the difficulty in this process. Okay, moving on. I'm gonna now talk about the machine learning cycle okay. I'm gonna also, there is a question about the risk and the issues using machine learning in document processing. This is a very, very good question. For sure, there is risk. But as I mentioned, there are a lot of regulations. So instead of someone having the document and processing it all the time, and usually you have most of these documents, you have to OCR them. They are images, they are scanned, they are not searchable PDFs. So so you cannot even copy and paste to somewhere, to your database. So what happened in these applications, we pull these documents from the emails, it comes, and then we process this document by extracting this text, OCRing it, and then extracting the entities. And then these entities next to the document will be presented. So instead of someone going through the whole document, you can just accept this document saying, yes, this is right, this is correct. So the process is way faster. Instead of taking 5 minutes, it won't even take 1 minute. It will take few minutes just to say, that's good. So there is no risk. And now I'm going to go through the cycle, and you will see that the bank will never accept risk. This risk, we try to minimize it. It should be very equal to the risk introduced by human. So now I'm going to talk about the machine learning cycle in the bank. I'm gonna start with the cycle, and I'm gonna come to the question later. How do we pull the documents from the email? First thing, we understand the problem completely, and we have to understand the requirements of this problem. And after discussing the problem and making sure that this is a real machine learning problem, we go back to the users and we say, yes, this is a machine learning problem. And then we have to start working on the POC for this problem. So to do the POC, what we do, we require the data. And we start looking at the data that we have. And then we can go back to the users and say, well, you know what, there is data that are missing. We need to source the data from another source. So usually, or many times, the data that you take is really not the data that you need. Sometimes you drop all these things and take another source of data, and this is what you really need for the machine learning. So this is the first step. And then we start working on the data engineering. Data scientists, machine learning specialists work side by side to engineer the database specialists that understand that database to take the information we need in the form we need, and having clear the data we want, drop the records that we don't need, and so on. And then the most sophisticated, I would say, process here is the feature engineering or enrichment. We start processing the data and understanding this data, and then we start to do mathematical or statistical or many applications. We apply it to the data to create our features. This process takes a lot of time. We go back to the users, and then we ask other details to see what are the things that can really separate these two classes if I'm talking about binary problem. And whenever you do more feature enrichment, you will go back and forth. And during this time, you also use your classifiers to see what are the features that you are, to how good these features are. Part of this process is also choosing the proper classifier. So if I am working with numeric data, something like really pure numeric data, I can use neural network, SVM, and others. But when I'm working with tabular data, which has a lot of categorical values, I have to go and to a decision tree based algorithm like XGBoost, the distributed random forest, and these things. We have to understand all the requirements to decide what is the best classifier for us. And then based on our requirements, what do they care about? The recall, the precision, what is their interest? We can do the machine learning design. We can combine two classifiers, we can add another one, we can we create our machine learning design. After creating the machine learning design, having the system really ready, we develop the system. Usually we do our POC with Python, but once the system wanna go to production, it should go with C++ or Java. Because you cannot bridge. It takes time to bridge to Python. It should be really fast, and everything should happen in real time. So we have to re-implement everything in Java, and then we have the system running in prod parallel environment as suggestion. And we start the model risk management process. And this is a very exhaustive process. They have to make sure that the system will never fail. They have to make sure what is the risk you are taking having this system. We test the system with the same model going 5 years back in the like the prediction will be back on the time. So and based on the complexity of this model and the risk it takes, the process can be more and more complicated. We have 4 tiers for the model. Tier 4 is the easiest, and tier 4, when there is a user interaction, the user is gonna come and make sure that everything is going well. However, the other tiers, when there is no really a lot of risk, the tier based on the risk. And after we go through this process, and it can take months to pass this process, and they can send you the model back, and they challenge you for many features and so on. After that, we can go on with the deployment, and then we work with the users to calculate the KPI, and we create the feedback loop. So sometimes you have to retrain the model all the time, and we have the model ready and it goes to production. Sometimes even going to production should go into many stages. So it's a long process, and it has a lot of monitoring. I'm gonna take some questions before going to the next slides. I'm not sure if I am good with time, but the first question is, what is the procedure of extracting information from emails? We have in the bank, we have something called Inbox Manager. It's just a developed tool. It's very similar to Outlook that we have it, but what it does, it takes the email and it extracts all the information from that email. So this has really nothing to do with machine learning. It's a software that is in-house developed to access the email, take any information you need from the email. And you you can do even sentiment analysis on these emails. You can do document classification. So and after everything can be extracted, the PDF files, any file that is attached, the sender, the everything in the email, because these things also can affect, and based on this information we know which emails we have to access and which we don't have to access. About production Python into C++. Do you make custom deep learning libraries in C++? Very good question. There is a question about customizing Python with C++. The training process is usually, we can make it in Python because the training is in the back. It doesn't happen real time. I don't need it to be real time. So creating the model can be using Python. However, accessing the model and predicting should be in C++. So the deep learning is going to happen in Python. We use the same tools, but then when we, like for example, I can talk more about Java on here because we use Java. Let's say H2O. We use it. We use our Python for our POC. It's like our lab. And after that, when we want to go to production, H2O has the Java implementation. So we create the model using Python. Even we do the auto training using Python. But when we want to go to the predict, we use the predict function that uses the model from Java. The same for C++. Could you clarify or why you use Python for POC? A very good question. Python is really easy. We can have the notebook and we just do experiments and it's quick. You have very easy functions to use it. So that's why we always use it. It's because sometimes you do the POC and the users are not satisfied. This is not what they want, or the data are not good, and you can conclude, you can have many things. So that's why we use it. We don't need to develop the whole system in Java if we know that it's not gonna work. It's not what they need. And after the POC, we do the contract. Yes, we want to continue or no. In production. Things in production. How often do you put things in production? A very good question. Most of our products go into production, but we don't have a lot of, I'm talking about in my team, we don't have a lot of, we cannot take a lot of machine learning systems. Like there are a lot of things waiting for us to work on it, but it depends on how much we can take, but it takes, so most of them are accepted and work on them because the MRM will challenge you and you will go back and back and back. So it's a long process until we have the system ready, but most of our system go into production. But you cannot say there are a lot going into production every year. We also have Center of Excellence. They do a lot of research, but especially for those ones, the percentage becomes lower and lower. In our domain, we try to do things that really can go into production. It's less research and more applied machine learning. So whenever you have more research, you have less chances to go to production, I would say. What has been the shortest time for? Good question. The shortest time for a problem to go to production, if this problem we have done it before. For example, the entity extraction, we worked on it a lot. We created all the tooling, and we have the implementation ready there. So I don't need to rewrite the code. I have my library, I have everything. So we are set up to do this fast. It can, and the shortest, it can be like 5-6 months. This is shortest. The longest, it can be 2-3 years, and people wait. It goes gradually, but to be complete in production, it takes really a lot of time. Sometimes you have to stay in prod parallel for 6 months just to calculate the KPIs and to choose on which threshold I need to cut to maximize my benefit. What is the acceptable precision and recall for to have this system in production? I'm not sure how good I'm with the time, but when the time is over, just let me know. I'm gonna go through this slide. This here we have the process, the real process, and the people that are needed in each stage until we have the system implemented and how they work together to have this system. So the first thing we do is I have mentioned these things, most of them. We have to mention to see if this problem is cognitive or not. If it's not cognitive, we don't work on it and we say this is not within our domain. If it is, we continue. We have 3 components, and each of these components has different people working on it. First stage, which is just the POC, we just propose the solution and generate a potential performance measure. So we say, these are the performance measures that we need. For this problem, we need, like, the recall is very important. I don't really care about precision. However, on other problems, no, I have no tolerance. I have no risk. The precision is the important thing. So we have to see what are the performance measures we need to go on with our problem. The first part is the data engineering, and here we need both data scientists and data engineers, especially the domain engineers, like the people who are working on this database and they completely understand this database to work with us, because sometimes you have, for example, exceptions happening, and the exception, the transaction, you have to look at how this transaction went and what are the processes that went through this to calculate these features. So if you don't completely understand this database, you cannot really do these things. So you have to work with the database specialist on this part. So it needs database specialists and data scientists. The data scientist also will decide what are the data sources that we need to access. Is this the good data source for us or not? And they will ask for additional ones. And the second one, the second part is the feature engineering. Here, mainly, it's only the data scientist or the machine learning specialist. And in this section, the machine learning specialist and the data scientist will work on the feature engineering, will make sure that these are the features we want, and they study this. And the last part is where the machine learning engineer specialist will decide, well, I want it this way, based on the performance measure, we have to cut here, or to accept within this threshold, what is the confidence that we need, and so on. So this, and then after that, the second part is when we want to send the system into production. And this, in this case, we need to for the data engineering, we need the data engineer and the users IT, because we work with different ITs. They will work on this one. And the feature engineering, the data scientist will give them to the developer to develop this. They will say, in Python, this is my code. And then they implement it. And they can come back to you and say, how do you do this encoding? Explain the cosine measure, how it happens. Explain exactly how do you do the edit distance. So the data science have to work side by side with the developer to have this process completed. And then after that, the machine learning engineers and the IT developer will set the system. And these are how the system goes into production and into stages. IT, when we are with the POC, they don't do anything. At the end, I just want to go through so quickly the two processes that mainly in most of machine learning systems, the training and the prediction. The training is we take the database and then we do the data engineering. Always the data engineering part should be owned completely by the user's IT, and machine learning, they just work with them to see what data they want. Then the machine learning on these systems. Then we have the feature engineering and the feature engineering and then the classification. The feature engineering part is always business specific. So this code will be rewritten every time based on the features we engineer. Because it is business specific, we have usually generic classification libraries because we reuse this structure of prediction. So this library is usually generic and we are reusing it. This is for predictive analysis. The same when we are talking about entity extraction, we have these libraries that are reusable. Usually the first project that is new in any problem takes the longest time, and then it sets up everything. Like we try to write the code to be reusable for whatever reusable, and then the model is created. This process, even if we do it in Python, even if we are training in Python, the feature engineering should be written, the features should be written in Java, and we should file that has the feature from the Java sourcing, because the exact feature we predict should pass to the classification. So we use the same code that we are using it for prediction, but then we create a file and then it can be done. The training is easily done by Python, and down we use the model that we have to predict and give the final score. That's it, all what I have. Please let me know if you have any questions, and thank you very much for your time.